Phase change memory. It's been one of those technologies, kind of like carbon nanotubes, where there's all this awesome potential and an endless stream of news stories about how super awesome cool it's gonna be and the latest breakthrough, when and if it finally ever makes it out of the lab and into a real product that you or I, the consumer, can actually buy. Well, that ends today. Intel sponsored our trip down to their campus in Folsom, California, where we will be taking an exclusive look at the latest breakthrough in some super awesome cool tech that they're calling their Intel Optane technology based on 3D cross-point memory media. And all of this is taking place in advance of you normal consumers being able to buy, oh wait, now that I think about it, that sounds an awful lot like all the other coverage of this stuff. But no, the difference this time is that an Optane memory module like the one I'm holding in my hand will be available for purchase in about a month for $50. Okay, so what is an Optane memory module? Here's the Cliff's Notes. DRAM is the super fast storage that holds the data that's integral to whatever it is your system is doing at a given moment. So when you go to launch a web browser or a game, a simulation data set or video editing program, whatever, that is where everything gets kept so that the program runs smoothly. So that's great, right? Let's just put everything in there, right? Wrong, 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 wrong. DRAM has two major limitations. The first of which being that DRAM is very expensive. You probably have less than 1/10 as much DRAM in your system as you have other types of storage. And number two is that DRAM is what's known as volatile. So that means when the system loses power, poof, the data is gone. So that is why we have what's known as non-volatile storage. So this is where your pictures or files or anything that you don't want to disappear every time you turn off your computer goes. And the most common types of non-volatile storage in order of speed are the hard disk drive, or HDD, the solid state disk, or SSD with a SATA interface, or more recently, an NVMe SSD like the 750 series right here. Getting back to Optane though, 3D cross-point memory is unlike anything we've ever seen before. At a die level, both its performance and endurance exceed even the NAND used in the highest end SSDs today, and perhaps even more importantly, it has only 10 times the access latency as DRAM, meaning that it can be used as more of an extension of system memory or like a fifth level of CPU cache. And it can do that without worrying about the write cycle limitations or long system stutters or delays that would be associated with grabbing data off of a more traditional storage device. And the real kicker then is this. It does all of this stuff while being non-volatile. The data stays there. So here is a normal computer. Intel did provide it, but I have checked. No monkey business. 7700K, ow, Z270A. I got a water cooler on there that, herp-a-derp with the RAM spacing there. It's got one fan on it, and you got a, what is that? GTX 1080 and a 3 terabyte WD Blue hard drive. So in summary then, this small 16 or 32 gig stick sits somewhere between your DDR4 RAM and your mechanical hard drive. So I'm thinking kind of there, but no, not really. Acting as a way faster data cache, allowing application launch times and system responsiveness up to several times faster. And this time, Intel claims, although we've all heard this before, that it's easy. So, let's try it out then, shall we? Action roll. Yes. Here we go. And here's the performance of a normal computer, if you can call it that. And I mean, I'm not just talking boot times, like click on things, how long you wait. Ugh. Okay, so now we're gonna put in the Intel Optane memory module. Let's shut this baby down eventually. At this time, that requires a 7th generation Core series processor and a 200 series desktop motherboard. You find an available M.2 slot. So there's actually 2 on this motherboard. Screw it in and boop, there it is. About 3.7 gigabytes per second of theoretical bandwidth to our memory. That was awkward. I was like, there's no button there. Finally, we reboot. And we're actually going to be measuring this, even though we are not expecting there to be any significant difference in boot time, since the Optane memory module hasn't had a chance to cache anything yet. And hypothesis confirmed. It is marginally faster, but there's also significant variance once you factor in waiting for all this crap to load up when you boot up Windows. And for that matter, this is true for everything we ran after initially installing the Optane memory module. On the second run, now we're talking. Here, Optane is starting to flex its muscles a little bit. Game loading times are not affected as much, but boot times and application load times are noticeably snappier. For our third run, ignoring the margin of error inherent in relying on my fingers to press a stopwatch, overall the results look pretty darn similar to the third and still very good. So that was really cool. But with that said, I don't think anybody at Intel is trying to convince the enthusiast user who wants to give them $700 for a 1.2 terabyte NVMe SSD to throw that junk in the garbage and run out and buy a big old hard drive and strap a 16 or 32 gig Optane module to it instead. No, I think the pitch here is that in a typical consumer workload, the Optane module can hold enough of the operating system and program data to achieve SSD-like responsiveness at a lower cost without manually using frequently used data around, like many users with SSD boot drives and HDD storage drives have to deal with today. So this tech was already capable of measurable, noticeable improvements to system responsiveness back when it was called SRT, and it used slower, lower endurance NAND flash in order to accelerate the computing experience. So what we're looking at now then is a way for Intel to take everything that they learned about intelligently caching data for the user and give it the low latency, high endurance, and simplicity that it always, I guess, needed to really shine. So a huge shout out to Intel for sponsoring this video, bringing us down here to exclusively bring you this hands-on experience with their Optane memory module. Thanks to you guys for watching, and as always, if you disliked the video, you know what to do, but if you liked it, hit that like button, get subscribed, leave a comment letting me know, what do you guys think of this? Would you use Optane to accelerate a boot volume? Would you use it to accelerate even a secondary storage volume? What do you want to see this technology in? Because I can tell you, this is not the last we've seen of it. And finally, check out at the link in the video description where to buy the stuff we featured, our merch store and our community forum. I'll see you guys